So the first solve was very straightforward. All I did was recognize what I had to do for the next step and then do that step and then pause to recognize for the one after that. Because the Ortega method is fast, I don't get bad times doing this, but it could be a lot better. The second solve was much more interesting. There were no pauses at all, and that's not because of superhuman reaction time. I'm not reacting to anything that's happening. Instead of pausing to recognize at each step, I've already predicted each step from the step before. So if you use the Ortega method and you don't want to learn a whole bunch of algorithms, you won't be as fast as if you did, but you can still get very, very fast using the Ortega method, and that's what this tutorial is going to be about. So the first thing I'll talk about is an overview of the Ortega method to make sure that you're doing everything quickly. First thing, make sure that you're color neutral. So if you're seeing bars like this, white and green, you're equally capable of doing either of these. Next, you have to be able to make faces efficiently, which means watching this video or one of the videos I'll link in the description for how to save moves while making your first face. Next, you have to be able to plan out the whole face during inspection and remember where the bar will end up or the fact that there will be no bars or a solved layer at the bottom. Next, once you reach the last step, which is PBL, you should be able to look at only two sides and not every single side to be able to figure out exactly where the bar is or the fact that there will be no bar. So for example, here, these are opposite colors, so that means there's going to be no bar. If these two are opposite and these two are not, then the bar is across from the opposite stickers right here. The next thing we'll talk about is learning just a couple more algorithms to save cube rotations on PBL. In the case where there's no bar at the top and one bar at the bottom, hold that bar at the back. If there's no bar at the bottom and one bar at the top, then you can hold this on the front or back, and there's two algorithms for it. Both algorithms are about equally good, and I'll show them both. So if there's a bar at the front, now for the same case of the bars at the back, there's another good algorithm for this. Now, if you have a bar on the top and bar at the bottom, if you get it in this case where they're at the back, if the top is solved and the bottom has a bar, hold that bar on the left side and do a T perm, but beginning with an R prime and ending with an R2. So R prime is the first move. Then after you're done, do R2. If the top has no bars, originally I taught Y perm, but there is a faster algorithm you can use for this, and that goes like this. If the top is solved and you have no bar on the bottom instead, you can actually do the same algorithm, but it just ends a little bit differently. Here, instead of doing F2, you do R2, B2. The next step is being able to predict OLL during inspection. So if you're able to quickly determine efficient faces, then you should start working on tracing through OLL so that you can predict OLL during inspection. So for example, here we have orange bar, and how I'm going to solve this is by moving this one in and then solving this one into the back. And what I noticed from this is I'll have a bar here and not here, so there's just going to be bar in the front, which is not what we usually want, so I'm going to do this instead and solve it from the back. So I'm going to get L prime for this one, and this one gets inserted with L prime, U2, L. So in total, it's L2, U2, L. So what we're going to do is look at the red pieces only because that's our last layer color and trace through 3 of them and deduce the OLL using only those 3. So I'm going to look for the easiest ones possible. L2 hides this one at the back, and then U2L just brings it back up. So this one's just going to end up like here. So red on the side here, and just remember that. All right, this one is going to do L2, U2, L. All right, so we have these two so far. Then I only have to trace through one more, and I can choose either one of these depending on which one I think will be easier. I'm just gonna go with this one. So L2 puts it at the back here, U2 puts it over here, and then L. So here, here, and here. And from that, you should be able to deduce exactly what OLL this is gonna be. The last one's gonna be right here, and this will be a pi OLL. As long as you keep practicing at it and making sure you don't forget the things you've already tracked, then it will be quite easy to do in 15 seconds once you give it a lot of practice. The next step is more advanced. It is predicting PBL during OLL. So just looking at the OLL green stickers, I know what to do here, but I don't know exactly what the top is going to look like, whether there will be a bar and where that bar will be, or whether it's going to be solved. So in this case, you have to do CLL recognition. Now, you don't have to learn any CLL algorithms, you just have to be able to recognize the same way you would for CLL. And you can watch my CLL tutorial for recognition tips, but I'm also going to go over here exactly what you have to know. So just an example of what I would do here, for this soon case, then I always look at these 3 stickers, and these give me a pattern that tell me what the top is going to look like afterwards. And in this case, I noticed that these 2 being the same, and this one being opposite, then I just remember that it's going to end up on this side, the bar. So there's the bar. So on the screen here, I have every OLL from the same angle that I taught it in my Ortega tutorial. Those are good algorithms, and if you don't use them, then you are going to have to figure some of this out for yourself. All right, so for each of these, there is a pattern that gives you a solved top, and you have to memorize what these look like that gives you a solved top. You can see these for yourself if you take a solved cube and do the inverse of the algorithm that would solve this OLL, and you can see that these stickers here are the pattern I'm talking about. All right, then you also have to memorize what it looks like for if you're going to get no bars on the top. These seem like you have to memorize 14 new things, but in fact, these are just the opposite patterns of the ones that I showed a second ago. Now, what I mean by opposite, if you take a look at the example for the H case, instead of being vertical bars, they are now just horizontal bars. That is the opposite case. So you can kind of find the logic for all of these, why they are the opposite case. And so if you can recognize both of these, then you will always know whether the top is going to be solved or whether it's going to be no bars. However, if you get any other case besides the ones I've shown here, then it is going to give you a bar no matter what. You don't know which side that bar will end up on, but you do know it's going to be a bar, and this will help you predict the PBL case, not perfectly for the bar cases, but it will immediately tell you what you have to do for PBL. Now at this point you might be thinking, why am I doing this? Well, if you go learn CLL instead, you'll also have to know this. And if you want to get really good at 3x3 PLL prediction, then you have to learn this as well. So if you want to get really good, whether it's 2x2 or 3x3, this will come back to you eventually. So just an example here of how you'd exactly put this to use. On the bottom here, I have no bar, so I'm just going to remember that. And then on the top, what I'm going to do is get here, and once I'm experienced with this, I'm not actually going to pause to look at all 3 before doing the OLL. I'm going to have a glance at this as I start my OLL. Think about that as I'm doing it and realize, okay, that wasn't the regular pattern, that wasn't the reverse pattern, so it's going to be a bar. So if you've made it this far, you might be wondering, for the cases where I do get a bar, it can show up on the front, left, right, or back. How do I know which one is it going to be? So that's the last or second last step in improving your times with Ortega. So here my red side is solved, I have an orange last layer, and I notice that from this, this, and this, they don't make the pattern needed to get a skip, and they don't make the pattern needed to get a diagonal swap or no bars. So in this case, I'm going to get a bar somewhere, but I don't know where. So for this particular OLL with this particular algorithm, there actually is a rule, and often you can figure out a rule without just memorizing what pattern makes which side. So the rule for this OLL is if you see 2 opposites, then the bar will end up on that side. So 2 opposites means the bar ends up here. And there it is. Now here's another case, 2 opposites are here this time, so the bar ends up on the front. Now what happens if you see matching stickers instead? Then that just means the bar is going to be on the other side. So if it was opposite, it's on this side. If it's matching, it's on the other side. So bar ends up on this side. So here's an example of how I go through the process of discovering where the bars are going to end up. So I get an OLL like this, and I don't know where the bar is going to show up, so I do the algorithm for it, and I see it shows up on the front. All right. Now I put this on the left side and undo that OLL, see what pattern I get, and see if I can come up with something for this, and then I will do it again. All right, so coming back to here, how I approach this case is I start by making a rule for what if I see 2 matching. So if I see 2 that match, then the rule I will use for this is that they always point towards the front or the right side. So this one points towards the front, so it makes a bar on the front. Now here again with these 3, I have 2 matching, and this one, I just imagine this one is pointing towards the right side. So there's going to be a bar on the right. Now if I get opposite matching pattern instead, then I imagine it points in the opposite direction of what the rule I made was. So since this normally points to the front, but it's opposite this time, it points to the back instead. So now I'm going to get the bar at the back. The rules for what patterns create what bar ends up where is really just decided by you, and it'll be a lot easier to memorize if you made it up yourself and it makes perfect sense to you. And also, if you think this is 2x2 specific, I use this on 3x3 as well. On 3x3, not every similar corner pattern will follow the same rules, but very, very often they will. So this actually covers a lot of 3x3 cases as well for predicting where the headlights are going to go. So in this case, they're the same. It's a U case, so it's going to go to the opposite side, which is one of the rules I explained earlier. So if you do this OLL, then usually you will do the algorithm for it with headlights on the left. And maybe you don't for this case, but I do for all of the cases. So that's why I find it really helpful for me. If you're interested, the video is up there. All right, now let's take another look at that advanced solve from the beginning of the video. During inspection, I traced through to see what the OLL was going to be and realized it would be a pi OLL. And I also made the first face efficiently while remembering that there will be no bar on the bottom, which I'll use for later. Now here, I knew what OLL it was going to be, so I didn't have to pause, but I still have to make sure that I look here and see what the CLL pattern is. From this pattern, I know that it doesn't match the solved case or the diagonal swap case, so I knew there must be a bar somewhere at the end here, and I just have memorized that it's going to end up on the right for this case. So right afterwards, I did U prime so I can start the PBL with the top bar at the back. Now, as I'm starting the PBL, I take a look at the front blocks here to know what the AUF is going to be. I know that for this algorithm's PBL, how to recognize the AUF or the U move afterwards is that all these blocks are going to move to the right. So I recognize the AUF had to be U2. Now the last thing you could learn is one looking. The reason you should never do this is because if you're that advanced at 2x2, just use the EG method.